All right, so we have Google Colab here. This is just the fastest way to jump in. The other thing I just want everybody to do, if you're following along, you'll see the file here. So just click File, New Notebook. And this creates the environment with you. So you can start coding with this. The other thing I just want everybody to do is to import the CSV file. So in the chat, I put in the CSV file. If everybody is able to download that and then just drag and drop. So you can do, it's the activities CSV. And right at the bottom here, you drop it to upload. It just gives you a warning that it'll delete it after 2 or 3 hours, but it'll you'll be able to access it for now. So this is in a storage space to be used for if you want to save something permanently. All right, so hopefully everybody was able to upload the CSV file. If anybody has any trouble, again, feel free to interrupt whenever. This is pretty relaxed. All right. So I'm assuming most everybody is set up in Google Colab, so we'll get started. All right. I'll be running this off of Jupyter just because it's off of my computer, and it's basically the same as Google Colab, but it's just running off my desktop instead of Google servers. But anyway, so just want to give everybody a quick background too. I think it's important to understand a little bit about Python, and specifically pandas, which we'll be focusing on. So it was first developed by a guy named Wes McKinney when he was working at a financial firm. He saw how cumbersome data analysis was with different programs such as Excel and SQL. So he built a program within Python that could handle larger sets of data and that could be more versatile and do more analytics relative to Excel and SQL. So he developed pandas. And by the end of 2009, it was open source. And this graph shows the popularity of pandas over time. And it quickly bubbled into one of the most popular languages in Python, still is. So anybody that's worked in Excel, you'll notice that once we start going through this, there are a lot of similarities. It's meant to be that way. Pandas stands for panel data, which is what Excel and CSV files are. The last thing I want to focus on just in terms of pandas is just how useful it is in industry. So it doesn't matter if you're in finance, aerospace, energy. At this point, most major companies are using Python, specifically pandas, to work with data. So I just highlighted a couple of companies: Postmates, Spotify, JP Morgan, Tesla. But if you go on LinkedIn or any other job site and you type in pandas into the search bar in jobs, you'll see thousands of companies pop up that are looking for people with those skills. So if you're specifically looking to develop technical skills, pandas is probably one of the best ones to know, just because how ubiquitous it is across industries. All right, so now that we have the background through, let me just summarize the workshop really quickly. So whenever we have a project, we need to know the goal and the end state that we're hoping to get through. So that activity CSV, I'll bring it up if anybody else wants to bring it up on their end too, just to take a quick look at it. It is a summary of fitness data. Let me just expand this. And what we are going to do is we're going to clean this, summarize it, and graph this out. And the specific category the column we're going to focus on is calories, specifically calories burned. So in this workshop, we want to understand how many calories are being burned for all the runs that are for in this fitness data, how it's related to the other variables, and we want to get some summary statistics out of this. So that's the end goal, and that is called exploratory data analysis. So exploratory data analysis means that you're cleaning data, you're summarizing it, you're understanding it, and you're visualizing it. And that's going to be the goal, just understanding how calories are burned, what the average calories burned are, how they relate to other variables such as how long we run, and we'll yeah, so that'll be the end goal. All right. So for anybody that's following me, we're going to start coding now. The first thing that we do is we need to, and again, if anybody wants to interrupt, feel free if you're stuck on something, especially now that we're getting into the coding. We need to import a bunch of different modules. So we do this with the import. The first one we do is import pandas as PD. And you'll see that once we start to work with the data and call pandas, we're going to use PD. And this is just the syntax that everybody uses that works with Python and all the other libraries. Next one we want to work with is NumPy. This is a library that's similar to pandas, and pandas is actually very closely related to. And then the final two are import Matplotlib. That's a graphing library. And if you're importing it, import matplotlib.pyplot as PLT. Again, this is just the syntax that everybody uses. And then the final one is also a graphing library. It's called Seaborn, and it's import Seaborn as SNS. All right, so those have been imported. Great. The other thing I want to highlight for those of you that are starting, one great thing about Python is how easily you can get information on a function or a library. So say that we want to just learn more about pandas or NumPy or another thing. We can, anytime that you want to print something out, you type print, then you want parentheses around there. And then we're going to do PD, and PD references pandas. Then you're going to put a dot or a period, underscore, underscore. And if you're using Google Colab, a notebook, or almost any other IDE, actually, you can autofill things by hitting tab. And if you just want to do that, and you'll get used to it as you start to type in. So I'm going to type with tab doc. So I just want to highlight this one, especially if you're getting started. You can do .doc, and this will summarize the package that you're working with. So it gives a summary of pandas, what it's used for, and just this is good when you're starting to work with stuff. And let's do it for another library. So let's do it for NumPy this time. So np.doc, and same thing. So I think that's a good one to know, especially if you're just starting out. You can call this for any function or any library, and it'll summarize it. All right. So let's move on to actually working with the data. So we're going to now import the CSV file that we moved into Google Colab into a data frame. A data frame is, think of it as an Excel spreadsheet where all our data will be stored. So we'll do that right now. So PD, we're calling pandas, dot, read, and let's hit tab. And you can see here that that pandas can handle a lot of different types of files. So not just CSV or Excel files, but it can handle HTML, JSON, and a bunch of other stuff, SATA, SQL, SAS. So if anybody works with those file types, you can easily work with them in Python as well, or import them in Python and work. So we're working with a CSV file. So be sure that you hit pd.read CSV, parentheses, and then you want apostrophes. And then you want to type in the name of the file, activities.csv. All right. And we're going to set this equal to so the data frame, this df. Again, this is just the syntax that everybody uses for data frame. This is going to hold all of our CSV data. So I'm just going to also print this out. All right. So our data is uploaded. So if we want to toggle back to activities on the CSV file. So it's, yeah, we can see that it came through activity ID, date, activity name. So it looks all good. And if you're particularly working in a notebook or Google Colab, it looks really nice. Which is why I really prefer to work in Jupyter or in Google Colab, because it summarizes everything so nicely. All right, and this also summarizes the dimensions. So we have 247 rows of data and 21 different columns. All right, great. So let us move on. So we read the data in. Now let's take a look at something called data types. So we're going to hit the print, parentheses. We're going to call the data frame again, so df. Then we're hitting a dot, dtypes. And dtypes brings the type of data that are in each column. All right. So this gives us a summary of the type of data that we have, which as we get more into it, it'll make sense why this is important. For the first one, activity ID, the type of data that's in here is an integer. That's what int stands for. Activity date is an object. Usually object stands for characters or strings or letters, but it can also denote mixed data. So you might have a column that has characters and numbers in it, but most likely it's just characters. So if we look at activity name, for instance, it's just the name of it. So that's the type of object that pandas recognizes that as activity. So distance in kilometers, that's a float. So integer is a whole number, float is any number with a decimal point. So that anything with a float is a number that has decimal points or is a fraction. Then we have bool. Bool stands for true or false. If you want to dig into it more by yourself, feel free. But it'll be good to know once you start digging into pandas or Python in general, or coding, because Boolean values are across. So Boolean just means true or false. And for the commute, is it a commute? And then it's a true or false value. All right, so we have an idea of the type of data we're working with. Next, we want to start cleaning some things up. So if we look back at the data frame here, there are just a few things that I know from the data that I just won't need. So activity ID, this is just a arbitrary number that was given by the app that I use that I exported the data from. So we can just get rid of this column. There's also another commute column. This is never used, so everything's false. So we just want to get rid of this column as well. There's also a column in between here that's named file name. It's not popping up because there are a bunch of columns. But anyway, we'll get rid of that one as well. So we're going to start editing our data frame. So again, we're going to call our data frame df.drop. And the drop function is obviously the row, column, or data that we're going to look to drop. Then we do parentheses, and we need to tell it whether we're dropping a column, a certain cell, or a row. So in this case, we're dropping whole columns. So we need to type columns, set it equal to, and then brackets. And then next we're going to type in the name of each of the columns that we're dropping. So the first is activity ID. The next is commute. And then the last one we're dropping is file name. And you just want to be careful to type the column name exactly as it is, because if it's lowercase or uppercase and it's not lowercase or uppercase in the actual column name, you'll get an error returned to you. All right, so we have all those typed in. The next thing that we need to do is we need to tell pandas to make this a permanent drop. So we need to type in place is equal to true. So in place is equal to true just tells pandas to make this a permanent drop. All right, so we have that all typed in. Let's run it. And you can see here that the activity ID is no longer here. We have the activity date, activity name. So pandas correctly read that we want to get rid of the activity ID column and the other two columns. Great. All right. So the next thing we want to do is clean the data a bit more. So we got rid of the arbitrary columns that we know that we don't need, but we see that there's other columns here that have a bunch of NA values. So NA means not a number. What it usually means is it's a blank. It's blank within the CSV. So if we toggle back to the CSV and look under activity description, this column is completely blank. There's no data at all. So we can get rid of this and the other columns that have no data whatsoever. And again, pandas makes this super easy to do. And that is why I love it. All right. So let's work on getting rid of all of these. But there's also, we need to also be aware that there might also be some NA values in other columns that we're just not seeing. And we need to look for those as well. So one way to figure out which columns have those blank values is we write the following code. So print parentheses, call our data frame again, df dot is null. So this function identifies all the null values within the rows or columns. We need to put in another parentheses, and then we need to put in a sum, dot sum too. So this will just sum up all the null values within the column. So we have 247 rows here. We know that all of these are blank. So when we run this, it should be 247 if everything is correct. All right, so let us run this. Also, I forgot, but you guys are some of you are new to coding. If you want to run a cell, it's Shift Enter in a notebook. So whenever I'm doing this, I'm hitting Shift Enter. It'll be different if you do it off a IDE, but a different IDE, but let's just go through this. All right, so Shift Enter. And this gives a summary of all the null values. So looks like it is correct. We see that activity description, totally blank, same for relative effort, and a few other columns. We'll also notice that there are columns that are missing a few values. So max speed is missing one value. So are some of the elevation columns, as well as calories, which we want to focus on. So there are 20 missing rows within the calories column. So let's first deal with the completely blank ones. We want to get rid of that. All right. So one way to do it is we call it df, calling the data frame again, dot drop NA. So this time, this function is specifically for columns or rows with NA values. And we're going to get rid of it based on what we passed into the function. All right. Parentheses, then axis is equal to columns, and that needs to be an apostrophe. So we're just telling the function that we're dropping the columns and not the rows. Comma, thresh, and thresh stands for threshold. If I'm going to pass a threshold of 114, it's a bit arbitrary. So what this is telling the function is that if there are 115 null values within a specific column, to just get rid of it. If there's only 100 null columns, it'll still keep it because it doesn't go past that threshold. All right. And then finally, in place is equal to true to, again, make this permanent. So let's do that. Comment this out. And I'm going to run the data frame again. Nope. Yeah. So again, you have to be careful with the spelling. So miss the H on threshold or thresh. All right. So it looks like it went through. So we can see that all those columns with the NA values are totally gone. So we were able to clean that part up first. Now we have to go back to the other columns that are that have just a few null values. Summarize those again. Great. So you can see that those 247, all those columns are gone. And then we have these. So obviously, if there's only one missing value within a column, it doesn't make sense to get rid of it because you still have 99% of the data in there. Same thing for calories. You have a very high percentage of calories that have actual values. So we have to figure out what to do with these null values. What you'll see a lot in data science or any type of data analysis is that people will replace these null values with either a mean or the median of the data. Mean meaning the average of the data. So, for example, let me just call df, and when we want to call a specific column, we do we call the data frame df column, and then the name we want to pass in the name of the column, max speed. And if I run this, it'll just return just that max speed column. All right, and I want to specifically know the average max speed. So the way that we do this is we hit dot or period, mean. Mean just means average, parentheses. We run this again. So this is the average speed for the max speed. So it's average that whole column, and this is the number that we have. So if you were doing an in-depth analysis, you have to really review the data before you chose to replace it with the mean, but this is just a simple workshop. So we'll just choose to replace everything with the mean. All right. So there are a couple ways to do this. First, I'll show you the clunky way that if you're new to pandas and Python, you would probably do it this way initially. I am just going to copy and paste this because it's a lot. So we have the column here, df, max speed. Then we have a function, fill NA, and it does exactly what it says. It fills all the NA values with whatever you pass into it. In this case, we're going to pass in the average for each of the columns. So remember, we just looked at the mean for max speed. So all the NA values, which is just 1, will be replaced with this mean right here. And then it's just set. So this is the slower way of doing it. Then we have the better way that most likely if you're new to Python, you wouldn't be able to do this without some searching around. And let me just, for those that are following around, I'll paste this code right now so you don't have to type away at it. I might have to get out of my shared screen, sorry. All right, for anybody that's following along, they could use that code that I just put in the chat. Let me share my screen again. All right. So this is, it may be a seemingly fancy way, but once you start working with pandas, you'll be able to read this relatively quickly. What I'm just saying is check for all the null values in the data frame, sum it up. Then what this line is saying is if there are any null values within that specific column, to fill in that data frame with the mean of that column. And again, as you work more and more, you'll learn about for loops and list comprehension, things like that. And this will become relatively easy to understand. And it's really good to know this. And again, the learning curve is relatively, it's not too sharp at the beginning. So you can pick this up pretty quickly from what I've seen for most people. All right, so let's run this. All right, and I want to check if this works. So I am going to do the null sum again. Great. So the code was able to loop through and it was able to fill in all the null values with the mean for each of the missing data. So that's for calories, all the elevation, and the max speed. So we've, at this point, we're able to clean up the data, got rid of all the null values, and we are working with pretty much the data frame that we need to be. I think there's one more edit we need, just another look at the data. So it looks a lot better than where we initially started, where we had all these NA columns and a bunch of different columns that are not useful. Now we have the columns that we just want to focus on. Great. All right, let's move on to the next thing. The next thing is we need to, if for anybody that's done any data analysis, you'll know about time series. If you want to do any time series analysis with data, it's best to convert this to a specific data type within pandas known as date time. And that will allow you to graph a little more easily and conduct time series analysis with the data. We'll actually see this once we graph out a few things. All right. So we're going to call the df bracket, and we're calling the activity date because we want to change this. Right now, pandas is recognizing it as an object. So we can see here the activity date is object. We want to change this into date time. And this will hopefully make more sense once we get further into this. But let's put in activity date. Remember the brackets in the apostrophes. Set this equal to, and we're going to call the PD function, so pandas dot to date time. And this will convert the type of data again. That right now it's object, we're converting it to this date time. Parentheses, df for our data frame, brackets, and then we're calling activity date again. Great. All right, and then I just want to check that this went through correctly. So I am going to print this out, and this will return the type of data it is. All right, so let's run this, shift enter. All right, what did I do? Oh, sorry. Yep, see, I didn't put in date. All right, so it does look like we were able to change the data type correctly. So dtype, date time right here. So this, again, this will make more sense as we start to graph things. All right, so at this point, we're done editing the data frame, and we're moving on to, there is one other thing that I want to filter. So I want to focus on calories burned specifically from running. So there is some activities here that are ride, which means biking. But I just want to focus on, I'm just trying to optimize the calories burned from my runs, and I don't want to look at the rides. So we're going to filter this out. All right, so we're going to come down here. We're going to filter out the rides, df, and we're going to filter out equals, call it DataFrame again, df dot lock, and lock just means that we're going to focus in on a specific column or row and edit it or filter it in some way. Then we're not doing parentheses, we're doing a bracket here. So bracket, we're going to call df activity type, and this is the one that stores the whether it's a run or if it's a bike ride. So that's in brackets as well. And we have the apostrophes, then equals. So you'll notice here that there's a difference between 2 equal signs and 1 equal sign. 1 equal sign is when you assign something a value. So we have the df variable here. We are assigning the data frame to df. Whereas the double equal signs is a comparison operator, meaning if we want to compare if something is equal to something else, we're going to use equals. So for example, 0 is equal to 0, true. And if you wanted to try to do 0 is equal to 0, you'll get an error because Python thinks that you're trying to assign 0 to 0, which you can't do. All right, so we are going to filter on runs. So we need to tell the function that we're filtering on runs. And we'll print out the data frame again. Let's run this. All right, so it looks like it went through again. And we just have the running data. So we filtered out the rides. And we can just focus on the calories that have been burned from running. All right, say that you're like me and you prefer miles rather than kilometers, because that's what we're with. So I apologize if anybody uses kilometers instead. That's how it is. But we'll create a new column that holds the distance in miles. So I'll show you right now how to create a new column. So we'll call df for data frame, bracket, and we need to put in the name of the column that we're going to be creating. So we'll call this distance in miles. So once we create this, it'll come up on our data frame, and it'll come up on the end of our data frame once we have it in there. Then equals, and then we need to tell it how to make this column. So we're going to make this column by going off of the distance in kilometers and converting that to miles. So right now we'll call the kilometers column, so df bracket and distance in kilometers. And then we can do operations on this. So the operation that we'll do is we'll multiply this. And for anybody that's using the notebook from GitHub or the download, I made a calculation error. I didn't divide it, but you can edit that out yourself if you see what I'm talking about. So it should be 1 divided by, this is the approximate value, 1.609. So if you want to just approximate it, you don't have to write out everything. You just need to put 1.609 and that'll approximate it. So what we're telling pandas to do is we want to create a column distance in miles, and it's going to be based on distance in kilometers multiplied by this fraction. All right, so let us run this, and I'll call df, and it looks to be correct. Anyway, so we have the distance in kilometers. So we know that kilometers is roughly 75% greater than miles. So yes, miles are less than kilometers, and it's roughly 75% of 3.22. So that calculation looks to be right. So we have input the column that we want to work with. All right. So now that we have all the columns that we want, we can now describe some simple statistics about all the columns. Scroll down. And a great way to do this is to get summary data is df.describe parentheses, and this will output some summary statistics on our data frame, on all the numerical columns. Let's run this. Great, and we see all the columns here. We first have count. So this is the number of data points we have in each column. They're all the same, makes sense, all the data points. Then we have other things like mean, standard deviation. So let's focus on calories, since we're really, that's the column that we're interested in. So mean is 320.9. So that's the average calories that are burned during a run. So if I was just to guess, if I were just to go run and guess how much calories I would burn on any average run, I'd probably guess within 320, because that's what the data is summarizing here. And we don't have a crazy amount of data, but we have enough of data. We have enough data samples or individual runs where we can make some sort of estimate. So, and we can think about, yeah, based on the 2.9, 3 miles, 2.5 miles that are usually run, 320 sounds right. So if we're going on a run and we want to mentally track how many calories we're burning in that run, good average is 320. Standard deviation, I'll keep this as simple as possible, but that's the variability of the data. So a very, very crude way of doing this is we can set a range. We can add 179 calories and subtract some 179 calories from 320 and say, for most runs, we'll assume that they're within that range, somewhere between the low 200s or the high 400s, high 500s. So this helps us see how variable it is. So if this were just, if the standard deviation was just 50, then the band would be tighter. So there'd be less of a chance of going outside of that band. Next is the minimum that was burned. So the minimum was 60 calories during whatever run. Then we have the different quartiles. So the 25% quartile, that's 224 calories. Goes up as you go up the quartile. So 50% is right at 278. And then finally, the max that was burned on an individual run is 1,392 calories. So we can clearly see that there can be some big variability between these 60 calories that were burned versus the 1,392 calories. All right. Then we can also kind of relate this to all the distance in miles and go through all that. All right, so describe that. And now we're going to move on to the graphing part. If anybody is doing anything off of that's not on a notebook or off of Google Colab, then it'll be printing out all this stuff will be a bit different, where you'll have to do plt.show. But if anybody has any questions about graphing and they're not using a notebook, please let me know. I'm more than happy to help out once we're done running through the workshop. All right, so let's focus some more on the calories column. So we want to graph this out and get a visual representation of all this data here. We will do this by graphing a histogram. So we'll start again by calling the DataFrame df df, and we want to focus on the calories. So brackets apostrophe calories dot plot. This will plot out the calories dot hist. Hist is a histogram, whereas you can have line graphs or bar charts or a bunch of other stuff. So you need to pass in the type of graph that you want. Parentheses, we're going to give it a title. So title is equal to calories burned in apostrophes, comma. We can set the color if we like. I like purple, so I am going to set it to purple. Purple. Then we could do an edge color if we like. Edge colors are just the edges of the bars, and I think it helps to have it. I'll just do black. Edge color is equal to black. Then the final thing is the bins. So for a histogram, you have to tell it how to bin the data. In this case, I'm going to do 50. I probably wouldn't do less than 50 because the data gets a bit too small after that. But what I'm telling it is we want each bar to hold initially 0 to 50, then 50 to 100, and so on and so forth. So let's plot this out. Oh, the last thing I'll say is if you're doing this, just put a semicolon on the end. This gets rid of the summary here. For anybody that's worked in Matplotlib, I believe this is from Matplotlib, so that's why it's there. Anyway, let's run this. So we have our calories graphed out, and it's telling us the same thing, the same information that we have here, but graphically. So we can see that most of the data is centered around here, somewhere between the 200, 300 mark. And we can see how scattered the data is. So even though most of it's here, we have a bunch of outliers where there was 800 calories burned, over 1,000, and we have that one big one out there. So we're just doing exploratory data analysis, but if we were modeling, this is good to know how the data is distributed. All right. So the next thing is I want to also look at a time series of my data. So I have an idea of how it's distributed, but now I want to look at the data over time to see if there are any seasonal effects. Am I running more during winter or summer? And the time series is pretty easy to work with. This is where the Matplotlib library module comes in. So we'll be using that to plot out this next time series graph. All right, scroll down there. All right, so I am going to call Matplotlib as plt.bar. And there's a bit of typing on this one, so just follow along. Parentheses, x. So we need to tell it that we're set the x-axis to the activity date. And again, since the activity date is now a date time, Matplotlib can work with it more easily than if it were just treating it as a string. So df bracket activity date. And this might not be the best way to do it, but we're going to do it as dot values. So what dot values does is it returns it as a array here. So you can see that that's what the df activity date value is. All right. So this is our x-axis. Next, we're going to set the y-axis, and that is known as height for whatever reason. So we have the height, set that equal to df, and then we want to specifically know about the calories burned. So brackets calories. Same thing, dot values. So just no parentheses on these. We're just typing in values, and that'll return the array. We're going to set the width of the bars. I'm going to set it at 3.5. Edge color equal to, again, I'm a big fan of purple, underrated color. And then the line width. And that's just the line width of the edge color. I'm going to set that to just enough so we can see it, but it's not overpowering the bar. So set that equal to 0.4. So edge color, just remember to put that in parentheses. Line width, we're passing in a value. So there. Then the way that Matplotlib works is we need to set some of these things separately. So these next things, the next thing I'm going to do is set the ticks, and I'm going to tell Matplotlib not to have it horizontally, but to flip it vertically. So I'm going to call Matplotlib with plt dot xticks parentheses, and I'm going to tell it to rotate the labels. Rotation is equal to vertical. So again, it'll just flip these tick marks to be vertical because there's a lot of values there. All right. We're going to set a title, so call Matplotlib plt dot title, and we're just going to call this calories burned over time, because this is a time series graph. Finally, we're going to set the y label, and we're just going to call that calories. So plt dot y label apostrophe calories. If you're following along, just put the semicolon or don't. All right, let's see, and we have it plotted out. So this plots out our data over time. So we have the various runs over time. So it starts right around July, June 2019. And we can see that there are spikes, and then it kind of slows down. And it does look like there is a seasonal effect, but unfortunately, because the data set isn't too big, it would be a bit of an assumption just to say, oh, looks like he runs a lot in summer, but then doesn't run a lot in winter. That might have been true for that year because of a specific reason, but we would probably need some more data, maybe at least 2-3 years of data before we could assume that there's some sort of seasonal effect with this. So yeah, January, sparse running there, pretty cold. And then starts to ramp up. Then we see a lot of activity this past summer because there was a lot of time to run this summer. So that's what I did for a lot of it. All right, so we have our time series. So say that we want to look at it over a monthly time period. We can summarize that pretty easily as well over with Matplotlib. All right. So the first thing I'll do is I'll explain this right now. If you look back at the previous data frames, you'll see that we have this index here. It might be better to go all the way. So pandas always creates this index, and you'll see this in computer science a lot. The index always starts at 0, not at 1. So 0, 1, 2, 3, all the way up to 246. And it's just the way that data is referenced within within computer science. All right. So what we can do is we can change that index to our date, and a lot of people do that within when they're working in pandas and with DataFrame. So let's do that. So df dot set underscore index parentheses, and we're going to tell it to set the activity date as a new index, comma in place, and again, this always makes it permanent, true. All right, so let's do that, run this, and now we can see that the new index is the activity date. And this just simplifies things a bit more. So let's go back. We want to right now we have daily data, so these are separate days or intradays also, and we want to roll this all up into monthly data, and we can easily do that now that our data type is a date time. So let's make another one. So we're going to create a new data frame from the old one, and we'll call this df underscore monthly. So df underscore monthly. So this is a completely new data frame that's separate from our df, just so we can specifically look at the monthly data. Then we set this equal to. We reference our data frame, our original data frame, df. Then we do dot resample, and resample allows us to change it from daily data to summing it up in months. So let's do that right now. Parentheses, 1 capital M, and that just means month, 1 month or monthly. And then we need to do a comma, or dot sum, and that will give us a data frame with monthly data instead of just daily data. All right, so let's run that and call df monthly. Great. So here we can see the monthly data. So this is June of 2019. The total time run this is all in seconds, 947 seconds. Then we look to July. There's a lot more activity, 36,223 seconds of recording. And it does it for all those dates. And it sums everything up. So it gives us the total distance run in kilometers. So this month, there was only 2.54 kilometers or 1.57 miles that were run. Next month, there was significantly more. But it does sum up everything, which average speed, you can't sum that up. So this is pretty useless here. Instead of sum, we could have done mean, which would have averaged out the data, but we want the total number run there. So just be aware of that, that everything was summed up, but not everything should be summed up. All right. So let us go on. And we're going to do the same thing we did in this graph, but we're just going to do it with the DF monthly. So I am going to go down here. And actually, I don't have the time. I hope I'm not running over. Sorry, I don't have it on my computer because I did. Oh, if anybody wants to drop off, feel free. I do apologize. I didn't realize how much time is going through, but feel free to follow through. I'll try to finish this up for anybody that's still interested. All right, so let's plot the last part of this. So we'll do plt dot bar to call. So we're calling matplotlib again. Bar. Set the x equal to df underscore monthly dot index, because we set the index equal to the date time, so we need to call that dot values. Again, this might not be the best way to do it, but for whatever reason I did it this way. Then we're going to set the y-axis, the height, then equal to df underscore monthly calories dot values, comma, and then set the width again equal to 3.5. All right, plt dot x. Similarly, we're going to rotate it vertically. Rotation. Well, I'm just going to run through this real. Actually, I'm just going to copy and paste this because this is the exact same thing as the other one. Great. All right, great. So I don't want to run over and keep everybody hostage here. I'm more than happy to run through this for anybody that wants to go through it, but I do want to hear from you guys if you were actually able to get on Google Colab, and even if you weren't able to code along exactly line for line, just want to make sure that you guys were able to maybe play around a bit, because again, that's the most important thing, is that you actually are able to access all this and play around.
Yeah, and this is Brendan. I'm TUDev president right now. I want to thank Adrian for putting together this awesome presentation. I hope you all enjoyed it and learned a lot. We're going to be doing things like this throughout the semester, roughly every 2 weeks. If you want to give a demo, please get in touch with me. I can drop my email in the chat, and we can talk through it and brainstorm any ideas, and then maybe help you practice a little bit if you'd like to do that. Otherwise, definitely come to all these meetings. We're going to be doing lots of interesting stuff throughout the semester. So I'm really looking forward to it. And thanks again, Adrian.
Yeah, and at this point, I think I'll probably stop. And if anybody has questions, feel free to chime in now. If not, just a few things I want to quickly highlight. But I'll, sorry, I see the chat is going on.
That's just me sending the follow-up contact info.
Gotcha. Yeah, but if anybody has questions, feel free to chime in. Otherwise, I just want to highlight a few quick things if you want to dive more into Python. So in our GitHub, I don't know if anybody actually accessed it, but you can download, there are a few other Excel files that you can play around with. I'll upload them to the chat right now. Well, I'll upload them to the chat after this. You can also, if you go to the GitHub, you can get all these links. A lot of people go to Stack Overflow right off the bat for any questions. Stack Overflow is great, but the actual documentation site is the best source, in my opinion. So if you go to the pandas documentation, it tells you how to get started, how to install it if you want to have it on your IDE on your desktop, bunch of different things, how to work with. I know that there might be some people in stat that use Stata or SAS. It tells you how to work with Stata, SAS, SQL, and I've done a little bit with SQL in pandas, and it does a decent job in doing that. So if you want to work across data, definitely the documentation, or if you have just questions in general, this is probably the best place to go. And the user guide will highlight everything that you need. So if you want to learn more about data frames, definitely the go-to. Close second is definitely Stack Overflow if you have a very specific question. But general questions, go to the documentation, I think. A few podcasts, if anybody listens to it. It gives you an idea of how pandas is used in industry and in academia as well. One of the podcasts is an interview with the creator of pandas. The other one is just how pandas is used and how to use it, how to optimize use of pandas. I linked a few basic videos if anybody wants to learn a few other things. These YouTube videos I thought were the most helpful out of the other ones. So this one is the basic introductory one. And then the bottom one here is a more hands-on one. So if you want to do SQL, this guy covers it. And then finally, article that I thought was good. It is again with the author of Pandas, Wes McKinney, and 10 things that he wants to change about pandas and changes that might be coming in the future. So for anybody that's new to programming, these libraries are very dynamic and they change over time. They won't change by leaps and bounds, most likely very quickly. Some might, but it's always being iterated over. And what was true 2 or 3 or 4 years ago might not work with the module now. So again, if anybody has questions, more than happy to email. I'll stop sharing now and I'll type in my email in case you want to reach out to me. Yeah, and yeah, thank you everybody for taking the time to come in. And yeah, hopefully we'll see you in the future.
Awesome. Thanks, everyone.
Thank you.